Hello, everyone, and welcome to our webinar, Developers Did You Know? My name is Jessica Malakian, and I'll be today's moderator. So let's start by quickly introducing today's speakers. For today's webinar, we have Raphael Ross, Anil Kotha, Alex Herbstritt, and Matt Baker. Raphael Ross is a senior product manager at Progress, leveraging his background in software engineering and product ownership to drive innovation within the OpenEdge product management. Since joining Progress in 2022, Raphael has played a key role in steering the product management of critical components within the OpenEdge platform, including the advanced business language, SQL, and the data server products. His passion lies in crafting solutions that not only meet customer needs, but also drive tangible business outcomes. Anil Kotha is a principal software engineer for OpenEdge ABL language, as well as a product owner for one of the language groups. He is responsible for the development of ABL language features and is currently working on projects like memory profile support in AVM, OpenTelemetry support within ABL client, and ABL collections, to name a few. Additionally, he is also making continuous improvements to CI/CD internally with latest IAC technologies. During his 14-year tenure at Progress, Anil worked on diversified Progress products and projects like Progress Developer Studio for OpenEdge, OpenEdge Data Servers, OpenEdge Mobile, Pass for OpenEdge, and many more important features. Alex Herbstritt is a principal software engineer and product owner with Progress. He has worked on maintaining and improving the ABL language for over 22 years. He has been a strong supporter of OOABL since introducing the strong typing system for object-oriented programming in the advanced business language. Lately, he has worked on adding the new archive library feature, supporting dynamic data masking, and supporting generic types in the ABL. And last but not least, we have Matt Baker, who is a software architect and product owner with Progress. He has worked as a consultant, QA engineer, software developer, and architect. Matt was one of the primary developers of Progress Developer Studio for OpenEdge and worked for several years on OpenEdge management. Now working on ABL language support, he and his team work on improvements to the ABL. Recent projects he has worked on include .NET support for Linux and Windows and Kafka integration with ABL. And now I'll turn it over to Raphael to start the presentation.
Thanks, Jessica. Good morning, good afternoon, and evening to all attendees joining us today. As Jessica mentioned, I'm Raphael Ross. I'm one of the product managers on the OpenEdge product management team. I'm excited to welcome you to our Developers Did You Know webinar. Today, we'll be covering 5 exciting new features included in the OpenEdge 12.8 LTS release. So first up, we have Alex Herbstritt, who will be covering 2 security-related features, dynamic data masking and also protected R code. These features essentially help you to protect your sensitive data and compiled source code. Next, we'll hear from Matt Baker, who many of you already know, who will be covering event streaming with Kafka by leveraging the OpenEdge integration with Kafka. And last but not least, we have Anil Kotha, who will be covering OOABL collections and also application observability with OpenTelemetry, which will enable you to better monitor and optimize your OpenEdge applications. So we're looking forward to getting your feedback and addressing any questions that you may have about the features. So without further ado, I'll pass it on to Alex to get us started.
Thanks, Raphael. So my name is Alex Herbstritt, and I'm going to be giving a demo of dynamic data masking. This is the only slide I'll be presenting, but I would like to go over, before I do the demo, a high-level description of what dynamic data masking is. Dynamic data masking gives the customers the ability to obfuscate or mask, hence the term masking, the data visualization from the database based upon who is requesting the data. It allows the original data to be stored in the database, but to be presented to the user differently, allowing sensitive data to be protected. This is a requirement for many privacy regulations, for example, HIPAA, and our customers need this feature to be able to modernize their OpenEdge applications, keep up with the security. Customers will be able to define who can see the sensitive data and therefore who cannot see the sensitive data by masking the values viewed by the application the user is running it. This happens at runtime, hence the term dynamic. The feature requires no changes to the application code. The work is done by the AVM and the database. An example would be you have an HR application for your company that covers all your employees. Now, a person in HR should be able to see all of an employee record. That's their job. While a manager should be able to see maybe most of it, but not everything. Maybe there's some personal data in there. But more to the point, a plain old regular employee should not have access to the private data about their coworkers. So the idea is you set roles and tags. The administrator defines these, and this tells you who can see what. So an HR person would be able to see everything. A manager would be able to see not everything, but maybe it would include their salary, etc. But a regular employee should not be able to see his coworkers, for example, salary, personal information about family, etc. So let's go ahead and take a look at a demo. So I have here Progress release 12.8 running on a VM. I will get into the demo directory, run the demo, and then go through some details. All right, so I'm going to run form1.p. That's going to bring up a login window. I will log in twice, once as a management person and once as a support person. You'll see what happens. So it's going to bring up the application. The database is already set up to support dynamic data masking. I'll touch upon that after I do the basic demo. So first, we're going to log into our payroll as a manager, account manager 1. And when we log in with the account manager, what we can see is a bunch of information about the employees. First name, last name, birthday, position, address, start date, etc. None of this is obfuscated or masked. This is the account manager is not restricted in any way. Now we'll go ahead and rerun the application, and this time log in as someone from support. So that was account manager 1, and now we will log in as support 1. And now the same application is running and the same data is being displayed. However, this data being displayed has been masked. You can see that the first name and last name are not complete. They have masked characters in them. Their position, their address, their city. And if we take a look at how that was done, we can take a look at the source here. So the application is only running run forms1 does login.class and employee info.class. The files here that are in this were done to set up the database, set up the roles, set up the tags, set up the partial masks. And now here I have the partial masks that show you what happens with the employee. Now we are setting up the mask for an employee, which is what support is. And they are going to get a mask on the first name field, and that is going to be a partial mask of show the first character, show star for up to 5 characters, and then show the last character. So if we look at the first name, there's 3 stars. That means there's 3 hidden characters. You can see here there's one with 5 hidden 5-star characters. So it's showing you the first and last character and 5 stars in the middle. The second masking you can see here says, don't start at the beginning, just show hash marks and then show the last 5 characters. And you can see that happening here with last name, 5 characters. Smith is only 5 characters, so it doesn't get masked. These names are masked with 3 each. And then if you look at the address, you can see it says show 5 characters and then nothing but Z's. And you can see in the address, it shows 10 space SM and then nothing but Z's. These are all partial masks. You could, of course, mask out the whole thing. You can mask out with different fields, but this demo, we're just showing a bunch of the different partials. If you look at the city is interesting. Show 1 character, show all question marks, and then show 5 characters. So if there are 5 characters or more than 7 characters, you'll see the masking happen here. All right, so that was the demo, and now I'm going to go on to the next topic, which is the protected R code in the AVM. So the protected R code is the new archive procedure libraries that we have added to the ABL. These allow you to digitally sign your R code libraries. This provides deployment application security so that you're ensured that your files are neither corrupted or compromised. To give an example, if you look at a standard application in the ABL, you have your compiled application code, you have .rs, you have your associated PL files. Those are susceptible to either corruption or man-in-the-middle attacks or code injection. So the idea would be that you have your application running with service.r, and someone could go in and replace that service.r with something else, their own version of service.r, or they could edit service.r with a hex editor and corrupt it and inject its code that way. So how you get around that is with the new sign procedure libraries. They are kept in a procedure library that has verification and signature information in it to ensure that they have not been changed. If you were to edit a file, change a file, delete a file, add a file, then the archive file would know this and reject it and not run it. So how do the archive files work? So they are based on the Java standard of archive files, and it has a manifest file telling you what files are included with it. So where we have PLs today, you have a bunch of R code in all one file, and you insert that on your pro path and run from it. Now you have a APL library file that you do the same things. You insert in your pro path and run based upon that. Additionally, you can sign these so that if someone were to modify any of the R code in it, we would be able to pick that up since the signatures would not match anymore. As well, we have a handful of built-in classes, the progress.archive namespace that give you some abilities to access information in your APL files. So let's take a look at what the APL contents are. So this is just a zip file using the Java archive format. And this one here in particular is signed. You can see I'm just doing a unzipped list of it, and it shows you that we have a manifest file as well as the SF and RSA files. Those are because this is a signed APL file. And then you can see that it contains main.r and service.r. If you were to alter main.r or service.r, their signatures would not match anymore, and they would be rejected. So how do we do this? First is we use ProPack, and when you ProPack, that creates the Java archive file that we call APL. It must be called an APL. And if you notice on the right, there is signature and validation. These are associated with signing them. If the signature is required, it defaults to open. It means that the only R code you can run in your application is R code from other signed files. That means that all of your application would have to be run in APLs. This is the most secure way to do it and the way we should be doing it in the future. But today we allow you to leave it as open so you can run both secure and unsecure as you migrate over. And then the validation on the none, warn, or fail, that represents how we handle when the .r file in there does not match what was put in. Validation would say we don't even validate it, we just take the .r out and run it. Warn would say let them know that there's something wrong with the signature, and fail would say don't load it. So the ideal way to run for your most secure application is signature required and validation fail. But as we transition and move forward, people need to get their old application moved over. You can use open or none and none or warn to do your migration. And then the ProSign utility is what you then take your archive and sign it. You just input your archive file and output the archive you want signed and pass in the signature information. The signature information is not specifically listed here because that is actually part of the Java jar signer information. And then finally, we have 3 new built-in objects. The archive info gives you the information inside the manifest file. And then the 2 enums, progress.archive signature policy IDs and progress.archive validation policy IDs. Those are used to give you immediate access to open, required, none, warn, or fail. So that's what I have for the protected R code. I will now pass it off to Matt.
All right, thanks, Alex. So let's talk a little bit about Kafka for OpenEdge. We'll do a little bit of talking about it, introduce some concepts and what you can use it for, and then we'll do a demo in PDSOE. We can see how it works. And I'll give you a little bit of background and go through a little bit of code with that, more as an intro, just to kind of whet your appetite. So Kafka for OpenEdge, what is it? And why do I want it? Well, Kafka is an event streaming service. It is produced by a company called Confluent. They describe the product as an event streaming platform. It consists of a server and clients in a whole bunch of different languages and available for different platforms. It's used by thousands of companies all over the world. This may be millions by this point. It's focused on high performance data movement, mainly moving data from one application to another. It's used for streaming analytics, data integration, and absolutely mission critical applications. Many Fortune 500 companies use Kafka, and it's a critical part of their infrastructure. Originally, it came out of LinkedIn. If you ever wonder how LinkedIn manages to move so much data and send notifications to all these people, well, the core of that entire infrastructure is hundreds of Kafka servers all communicating with each other, synchronizing and moving data and events around. So what is Kafka? Well, as I said, it's an event streaming platform. It consists of kind of 4 major parts. You've got publishing to streams, so the clients connect to a broker or a series of brokers in a cluster, and they publish and they write out to a stream or a topic, if you will, and they send a set of events. And we'll talk about what's an event in a little bit. Then you have consumers. Consumers read data off of those streams. They consume those events and they do something with it. In some cases, it's process the data and put more events back into the cluster. Kafka also operates as a store of stream events. So this isn't like JMS, where you send an event and your consumers receive it and the message is gone. Actually, Kafka has policy-based retention. So you can send a message and process it a week from now, a month from now, a year from now, whatever you want, depending on how much capacity you want and how many messages you want to store and how long you want to store them for. And then but the real value comes in the processing of the message streams. So with Kafka, you have consumers reading that data out and doing something with it. So they're responding to events, whether it's an alert notification, or it's a piece of a log file, or what have you. You would forward that information on to another system to actually do something with. So that's where the value is derived. So what am I doing with Kafka? Well, there's a bunch of use cases, and these are just a very few that I've kind of selected out for this topic here. You can use it to replace a messaging system. Say you have JMS or SonicMQ and you want something a little more flexible and open. Kafka, being an open source implementation, has a very wide ecosystem used by many products. You might want to replace your existing messaging system with Kafka. You could do log aggregation. Perhaps you have many systems and they send a stream of logs, whether it's operating system logs or application logs or database logs, what have you, and you want to centralize those. You could use Kafka as a transport or even potentially as a storage mechanism to move those messages to some centralized server. You could use it as a data processing platform. Kafka is very low latency, it's redundant. You can use it to move data between applications. Perhaps it's financial data, maintenance data, logistics data, customer record data. Example, if you have a customer that needs to update their email address or phone number, and you need to distribute that change from the web application out to your backend, which has multiple different applications, you may want to use it as a syncing mechanism. So you can fire an event saying, hey, a piece of customer data changed. I need to move that data to these other systems that care about, need to make sure their email address or what have you is up to date. You can also use it for activity tracking. This is actually where it came from. Originally with LinkedIn, is they need to process clickstream data. Hey, who's using my app? What are they clicking on? I want to provide the best features and make sure that pieces of my application are working absolutely perfectly and most usable. So what are people using most common? Things like that. The sky's the limit. These are just a few I picked out. So let's get back to our concepts. We have a record in Kafka. So this is a message, if you will. It consists of maybe some headers, name value pairs if you want, a key potentially. So a key could be anything from a customer or maybe a region ID, or you can leave it blank, whatever you want to do. It's pretty free form. And then a value. That value typically takes the form of maybe a JSON message or a line from a log file or CSV file, whatever you want. It's kind of, sky's the limit. It's up to you what the message is that you want to define. And of course, there's a timestamp so you can know when it was sent. There's a few other bits of data, but those are internal and not terribly important. Then we have producers. Producers are the client applications that connect to the backend and send messages. And then the opposite of that is the consumers. The consumers are processing streams and reading messages and doing something with them. And then of course we have topic, which we'll talk about a little bit more. And partitions is a means of scalability, if you will. So a topic is split into multiple partitions. Those partitions are spread over brokers and the clients know where they all are so that you can bounce the load across a very wide cluster of brokers. Topics, they're kind of like messages. You know, you can think of a topic in Kafka as a stream of messages, kind of like a log file, which has log lines with date stamps and whatnot. Kafka stream is like that. It's processed from the beginning to from the oldest message to the newest message. Typically, your client picks out the ones it wants, and it does something with it. The producers send messages to one or more topics. The consumers read messages off of one or more topics and do something with them. And as I said before, they're persistent, so you can process them. Consumers can connect to the brokers and process them when they want to. The most important piece is the backend. The backend is the server infrastructure, which is a Kafka cluster. So a Kafka cluster consists of one or more servers, typically 3, as many as hundreds if you want. There's also the concept of failover clusters, but typically you would have a set of hosts, and each of those runs some brokers, and each broker hosts individual partitions of a topic. So a topic has minimum 1 partition, and it may be replicated, it might be split, lots of different configuration options. So I'm just introducing these concepts really quickly so that if someone says, hey, let's talk about the Kafka cluster a little bit in more detail, you'll kind of know where it fits into the architecture. And then we've got scalability. So Kafka is all about throughput and scalability and failover and reliability. And this is all handled on the back end. And how do we do this? Well, you don't run one broker. That's unreliable. You run many brokers. And this is a little bit of a topic you can kind of view at your leisure a little bit more if you want to examine in detail. You can get more information. There's lots more you can dig into on the Confluent website. This is just a quick picture of how partitions are laid out across brokers. So you have partition on one partition from one topic on one broker and a different partition on the other brokers. And they can run ROG, and administrators have full control over as many topics as you want, as many partitions as you want. And this is a little bit kind of a diagram of who are producers and consumers. Well, a producer could be a mobile app, an ERP system. It could be a piece of sensor data, sending temperature data or wind readings out to the Kafka cluster. It could be a database. I want to transport through, say, Pro2 from one database, and I want to synchronize email updates to another database. And on the other side, we have the consumers. Could be a database. I need to read in those email change notifications, put them in a new database. Could be a cloud app of any sort, maybe a data lake, what have you. Could be an email alerting system. Hey, a sensor failed. Sensor went over a certain amount. I need to fire an email alert. Could be a microservice, what have you, or hundreds of microservices, if you will. So consumers and producers may be the same processes in some cases, but you can mix and match, and it's very flexible. The last piece in the Kafka ecosystem is connectors. We don't have a Kafka connector with OpenEdge, but there are hundreds, if not thousands of them out there. It's not difficult to write one, but Kafka has an entire framework called Kafka Connect, in which there's standard certified Java applications that plug into the Kafka Connect ecosystem and allow you to move data safely and configurable. So you don't have to write your own. If you want to move data out of the Kafka cluster to, say, Hadoop or Amazon S3, you download and install an existing one, configure it, and use that. So where does OpenEdge fit into this? Well, OpenEdge messaging is an API wrapper that we developed that unifies different messaging implementations. So we have a Kafka implementation, which is the only one we ship, but you could plug in an AWS or a Google or a Microsoft implementation on the back end, provide a unified API as long as you conform to the OpenEdge messaging API that we provide, and replace Kafka if you want. It's up to you. So what is OpenEdge messaging? Well, it's interfaces in the APL and basic framework. It's object-oriented. You can call it from procedural. There's really no limits, and I'll show you a little demo of that in a few minutes. Built on common OO patterns. If you're familiar with builder patterns, fairly convenient to use, fairly simple, and we have both producer and consumer implementations for Kafka. Our integration with Kafka, we don't actually ship the Kafka library. You have to get it for your operating system. In particular, if you're on Ubuntu or Windows or what have you, there's instructions in the doc on how to set it up. It takes a few steps, not difficult, but we rely on the librd Kafka library, and it's up to you to provide that. We do integrate the logging with OpenEdge, so if you want to capture the diagnostic data, you can do that through the OpenEdge log file, so you don't have to worry about managing some extra log files. There is also full configuration, anything from the librd Kafka library you need to configure. It's in there. We expose the API to do that configuration through your ABL application. And then errors from the Kafka library, they are handled and translated into ABL exceptions. So at the end of the day, you're just writing some ABL code to access the Kafka client, which is librd Kafka, and work with the ecosystem. So what does this look like? Well, from an ABL perspective, this is the message flow. It starts out with your ABL application. You have a record builder into which you plug in key and value pairs. Those get serialized and passed on to librd Kafka. And the final step is the Kafka producer, which is librd Kafka itself, publishes it out to the Kafka cluster. You don't have to worry about most of the wiring. We've taken care of pretty much all of it for you. You do have to write the ABL that could provide the configuration. Where's the Kafka cluster? What's the Bootstrap server I need, and things like that. On the other side is the Kafka consumer. It's kind of the opposite. So from the Kafka cluster, we have the Kafka consumer, which is in this case librd Kafka still. It takes care of the pulling and the reading the messages, and the ABL takes care of taking those messages and deserializing them from their network and native formats back into something that's consumable in the ABL, and then those are turned back into consumer records, which the ABL application can consume. So there's plenty of more detailed information on the OpenEdge website. Just search for OpenEdge and Kafka on the docs.progress.com, and there's a bunch of examples. So now I'm going to jump into my demo. All right, so here's my demo. I'm going to demo a Kafka consumer. I already have a Kafka cluster set up in the background. It's kind of out of scope of the demo, so we're not going to look at that. The only interesting bits I want to point out is this is kind of how the API works. We have the consumer object, record object, and we have a consumer builder object. We configure and provide Bootstrap servers. There's a few other things I've provided in here. I'm not going to talk about those. And then we build our consumer, and then we have our AVL application spins in a loop. It polls for data. It's a requirement of the way Liberty Kafka works, is that you have to constantly look for messages. Otherwise, it doesn't do any work. And then we get that message, we convert it back into a JSON because it comes through as JSON, but we have to do a cast. And then we'll pull out our message body and we'll put it on the screen. And so I'm going to start this, and it's just going to sit here quietly waiting for messages. So I'll move that over there. And with our Kafka producer, it's kind of the opposite. We have our record builder, because we're not consuming messages, we're building them. We have a producer builder, which is going to generate our Kafka producer, and then we have some variables for records and our message strings and whatnot. And again, here we provide our Bootstrap servers to our client to say, hey, where's the cluster? We provide our serializers because we're going to send some strings, and then we're going to build up a JSON object and turn it into a string, and it's just going to have a little simple hello world message in it. And we're going to store that message in the body of a record builder. Then we're going to send that, and we're going to wait for the response. The interesting piece is everything is async in this world, in the world of Kafka. So if we want a better demo here, we're going to sit here and wait and spin for that message to come back, and we take care of the asynchronous behavior for you. If I didn't care about the response, I would just send the message and forget about it and hope it gets there. In this case, I do actually want to wait for it. And then we're going to just notify ourselves that we sent our message. So I'm going to run this. What we should see is after bootstraps, you'll see over here our consumer who's sitting over here waiting for messages, received it, and we just got confirmation, just almost exactly at the same amount of time, that our message came through successfully and was sent successfully. So that is my demo, and I hope you enjoyed it. And now I will turn it over to Anil for his portion.
Thank you, Matt, for giving detailed overview on Kafka. Hello, everyone. I am Anil Khota, and I will be talking about ABL collections and OpenTelemetry support in ABL. Without further ado, let's delve into these features. ABL collections. This is one of the most requested features from ABL developer community. As of OpenEdge release 12.7, we have delivered 3 different collections from ABL. We will look into it more detail in the upcoming slides. So as you know, OpenEdge already provides a couple of collections via openedge.core.collections package in the previous LTS releases like 12.2x and 11.7x. And these collections are mostly built using temp tables or arrays. There are certain limitations with this approach and are a little slow in processing when we have hundreds or thousands of elements in a collection object. To solve these issues, OpenEdge has now implemented an efficient built-in collections that can be used by any ABL application. In order to support collections in ABL, we have added support for generics, which gives us type safety. That is, if you have an object of type A, say animal, it will not allow you to add another object of type B, say plant. This all comes out of the box. This is achieved via a new syntax with angular brackets notation. And also we have added all these collections functionality as built-in classes, which improves performance significantly in comparison with the traditional temp table approach. And these built-in classes are available under Progress.collections package. So the first one, we have delivered multiple collections functionality in phases. Like here is a quick recap of all the ABL collections. The first one in the series is list collection, which is delivered as part of release 12.5. And the second one is sorted set, which is delivered as part of 12.6. And third in the series is the hash map collections, which is available from release 12.7. So list collection, as the name suggests, it is the list is which maintains a set of elements to be accessed in the sequential order. When working with list, a duplicate set of elements are allowed here. So here are a few interfaces and classes that are added to support the list collection. iCollection and iTribble interfaces are at a high level and are common to all the collections in ABL. That is, common members which can be used across several collection types, and all of them are available in these 2 interfaces. Other APIs pertaining to list like add, remove, insert, etc. are added to the list class. And the last one is list iterator, which is used for iterating through the list, like accessing the next element and so on. On the same lines, we have support for sorted set collections. As the name suggests, elements in the sorted set are in sorted order, and no duplicates are allowed in here. Like that is, all the elements should be unique in nature, unlike a list collection where we maintain duplicate elements. IComparer and IComparable interfaces, which define what sorting mechanism we have to use in order to add an element to a sorted set, followed by some other interfaces like iSet, which is specific to the set collections, and also all the API pertaining to the sorted set like add, get, remove have been added to the sorted set class, that is progress.collections.sorted set class. Similar to the list iterator for list collection, we have a sorted set iterator for iterating through the sorted set collection object. Two of the notable interfaces like iComparable and iComparer, these interfaces guide us where a specific element has to be placed in the sorted set. Once a new element is being added to the sorted set, one of these methods like compare to or compare will detect where a specific element needs to be placed in the set. iComparable is the default implementation, whereas iComparer is the custom comparer where we ask OpenEdge developers to implement, like they can customize. This will decide the placement of new element in the sorted set. So here is a quick example of how we can perform a quick add operation to the sorted set collection. iComparer and sorted set variables of type animal are created at the beginning, after which creating a couple of elements like different animals that can be added to the sorted set and creating an instance of sorted set with the comparer object. And as noted above, the comparer plays a key role in the placement of elements in the set, then adding all the elements to the sorted set by performing add operation. So now let's see what are hash-based collections and how they're implemented in OpenEdge using the hash code function. So hash-based collections, as the name suggests, it is backed by a hash table. This hash table contains buckets for a set of objects. This leverages the hash code function, which is newly added to OpenEdge as of release 12.7. On the right-hand side, we can see a quick example on how a hash map are maintained internally. We have a set of buckets with certain indexes and each bucket holding a key and value as a pair. The placement of these key value pairs is based on the hash value that we get out of the hash code function. So one of the implementations around hash-based collection that is now part of OpenEdge is hash map collections. Hash map collection is collection of key value pairs. Map contains unique keys where each key is associated with a value, but values are not required to be unique. That is, we can have a map with employees as the keys and managers as the values, where employees are unique, but you may have multiple employees with the same manager. So hash map collection provides type safety, with the help of generics, meaning that the compiler ensures only valid types can be assigned for both key and value in a hash map collection object. Therefore, using built-in hash map collection wherever applicable in the ABL applications will definitely improve the development time. That is, with fewer issues related to the type inconsistency, and also benefits from the significant runtime performance improvements or existing ABL solutions like the temp table-based approaches. So here is a quick hierarchy of the hash map collections within ABL collection family. This includes supporting all the supporting classes and interfaces for the hash map collection. Progress.collections.hashmap or hashmap inherits from progress lang object, and that implements progress.collections IMAP interface. And this IMAP interface is the root interface for all the hashmap collections. In addition to these classes and interfaces, there are a few more supporting classes and interfaces specific to the HashMap collection as well. So one of which is the iHashable. This is an interface which allows objects to be used as keys. This provides the implementation for generating hash code by a hash code method for itself, and also capable of identifying when a key is considered the same via equals method. Hence, we have other interface, which is iEquality Comparer. There are times where an ABL developer cannot modify the existing typed class, or there are situations where you want to prototype or use your own hash code or equals method. then here is a solution for you. Like using iEquality comparer, we can do that one. All you have to do is implement iEquality comparer interface by specifying respective typed class, and you should be able to customize the comparer functionality so the elements can be added properly to your HashMap collection. So the next feature we are going to discuss is around OpenEdge applications performance. As you know, efficiency and performance of an application plays key role as the application and the customer base expands, right? In order to support this, we have enhanced OpenEdge to support automatic tracing using OpenTelemetry. So what exactly is a trace? A trace is a single process, say a request from creation to a written result. It can be a success or an error. So every trace can be broken down into multiple spans. A span represents a unit of amount of work, like actual process that gets executed along the life cycle of a trace. So let's delve into more details to understand what OpenTelemetry is and how OpenEdge is integrated with it. So here is a quick introduction of OpenTelemetry. So OpenTelemetry is a set of tools and SDKs that is used to collect, process, and export telemetry data. And the telemetry data can be of several forms like logs, traces, and metrics. So the metric support is available in the previous releases, and the 12 series we are providing support for the traces. OpenTelemetry also ensures a vendor agnostic approach. That is, we can use any telemetry backends like New Relic, Dynatrace, or Grafana to visually inspect what exactly is happening in our AVL code. So OpenTelemetry Collector is one of the key components of OpenTelemetry architecture, and it acts as a middleware, which is responsible for collecting and managing data. And this has two deployment models, an agent that resides on the same host as the application, alternatively as a standalone process completely separate from the application. So why do we need to implement this one in OpenEdge? As of release 12.7, OpenEdge currently lacks deeper monitoring capabilities. That is, when OpenEdge is part of a bigger ecosystem in our OpenEdge customer applications, that would be tough to identify performance bottlenecks, especially with respect to PASOE and AVM. However, starting from release 12.8, with the introduction of OpenTelemetry support for auto tracing, one can start tracing their application. This can be beneficial to OpenEdge developers and DevOps engineers and also system admins. And some or many of you are already using APM tools like application performance monitoring tools, and OpenTelemetry support will allow OpenEdge developers community to visually inspect or visually see the problematic areas on those platforms. So how are we using OpenTelemetry in OpenEdge? So we have developed a new library named ProOtel, which is a wrapper to OpenTelemetry. And for this MVP release, also known as minimum viable product for version 12.8, we are enabling trace information automatically across OpenEdge components, which includes able procedures, classes, and transactions. We can also inspect client-server calls via distributed tracing. That is, in the real world, there might be multiple servers sending requests from multiple clients, and some of them might be experiencing slowness. We can use this functionality to mitigate such problems and, yeah, to understand where exactly the bottlenecks are being identified. So how one can leverage this functionality? So there is no additional setup required with respect to your business logic. Yes, you heard me right. The customers don't have to make any changes to their business logic, and everything is done for you automatically. A minimal setup towards the config file is required though. All you have to do is like run your code with a new startup parameter named hyphen hotel config. That's the only thing that we need with respect to configuration. So here is a sample config file. As mentioned before, for a normal AVM client, we use -hotel config as the option. For passive clients, we update in OpenEdge.properties with open hotel config file as the new attribute that got added to OpenEdge.properties. Exporters can be of two types, OStream, which is mainly used for debugging, and similarly we have OTLP, which is OpenTelemetry Language Protocol, as the other exporters with which we can use HTTP and gRPC. So here is a quick overview of how OpenTelemetry Collector can gather data from both ABL and PASOE clients, such that hotel compatible platforms like APM platforms can show all the data in the visual format. So it is the time for a demo. In this demo, I'll walk through a distributed tracing approach using New Relic as the monitoring platform, and I'll also show how multiple ABL clients sending requests to the PASOE server, and behind the scenes, OpenTelemetry is tracing these requests, and everything can be visually seen in the New Relic platform. Let me switch to my developer studio. So here I have my developer studio environment, which has like bunch of ABL procedures and ABL classes. Some of them which are running on the client side and some of them which are running on the server side. So here I open my sales client. This is running. This is acting like a driver program on the client side and runs bunch of ABL procedures on the server side using this session parameter. Let me open up one of the server side executing .p. So this is orderlines.p, and all I'm doing is creating an object with Acme Sports. This is my imaginary company, like imaginary sports company named Acme Sports. And all I'm doing is creating a couple of routines for getting customers, invoices, order lines, etc. And after creating an object, I am invoking get order lines for fetching all the order lines information. So if you look at the order lines here, all I'm doing is getting all the order line information by looping through order line table. So the main idea here is to inspect how much time it took for exercising this routine on the server, and also how much time it took for exercising both this client side and server side procedures. So as I said before, we need a config file. So I have a couple of configs in here. Let's open up one of them. This is the server-side config file where I'm tracing all the ABL procedures followed by the class, which is Acme Sports. And similarly, we also have a client-side config, which is order lines. Here I'm tracing both sales client and orderlines.p. In the benefit of time, I have already executed this in the PASOE server, and the results are now already available in the New Relic environment. So let's go to the New Relic environment to see how uh, we can see the traces information. So here I am in my New Relic platform. Once we navigate to the APM and services and to the distributed tracing tab, here we can see all the requests that came to the New Relic environment. Sales client, which executed for multiple uh, ABL procedures like customer order lines and orders and so on. So let me open up sales client specific to the order lines to see how much time it took for execution. In summary, it shows like 277 milliseconds, but we have to understand where it spent more amount of time, or detailed analysis of where the amount has been spent. So if you look at this one here, sales client.p, which is at the client side, uh, and is internally making a call to the server side, which is request OE pass order lines. This is a new entry that we have added as part of the tracing support to delegate client to server communication. So if I expand all these underlying traces, you can see the orderlines.p has spent 124 milliseconds, out of which this is the constructor call for creating an object, which took only like 0.04 milliseconds. And the major chunk of time is spent on getting the order lines from the database on the PASOE server, which took almost like 115 milliseconds. Uh, this way we can understand the complete flow from client to server in the on the server side, um, also with the total amount of time spent getting the data from the database and running the password on the server side. We can also quickly look at how much amount of data it got. So we understand why it took 120 milliseconds. So if you look at the data here, like it got almost like 14,000 records on the server, so which took almost 120 milliseconds. This way we can trace all the requests from client to server. Say it could be multiple requests, multiple clients sending requests to the server, so we can trace accordingly on the New Relic platform side or any APM platforms. With this, I conclude my demo, and I request Jessica to facilitate any questions you may have on any of the things that we have discussed with respect to ABL. Thank you.
Great. Thank you, everyone. That was a fantastic presentation. And now we will turn over to the live Q&A session. All right, is everybody ready to answer some questions?
Do you want a response? Yes.
Yes, I am.
Great. Awesome. Okay, so the first question is data masking a new feature only for 12.8, or is it available on 12.2?
Yeah, I can take this one.
He gets the easy one.
I'll jump in. So yeah, that dynamic data masking is a new feature available in OpenEdge 12.8. Unfortunately, it is not available in OpenEdge 12.2.
The next question is, can we set/define what will be displayed in the masked fields without affecting the code?
Yes, I did say that. So the data masking feature is enabled and controlled through the database. So you do not need to make any code changes. You just define the roles, your administrator, and then you define the roles. And then as you log into the database under that role, the masking comes based upon that. So you don't need to change any application code. You just need to update your database to support it.
Great. Another data masking question. So data masking is done in client side? Question. If I connect directly to database, I still see everything.
Yes. No, I'm sorry. Again, it's the mechanism you connect to the database is based upon the role of the person connecting to the database. So if you connect to the database as a administrator, then you get the administrator role, and you may or may not be masked. But if you connect to the database as a regular role, then there would be masking. Single service anyway. It's as I said, it's the roles described in the database and how they are displayed to the client.
If we have more Kafka broker and records are stored, are they stored in all brokers or just one?
The answer is, depends on how you configure it. So with Kafka, a Kafka cluster, you would typically have several brokers, not one, but you can get away with it. And you can partition your data into, you can partition any particular one stream into multiple partitions. So when you send a record, it may go to one partition or another, and partitions are distributed across brokers. Go back and watch the video, and there's a slide that kind of shows a picture of it. And if you have multiple brokers and you turn on replication for partitions, then the partitions will be the individual partitions will be replicated, and they can be replicated across multiple brokers. So depending on how many partitions you have per topic and how your replication factor is set up, the answer is yes.
This person wants to know, is the OpenTelemetry option possible with 12.2?
No, actually, this support from AVM is provided in 12.8. So we have to have 12.8 OpenEdge in order to work with OpenTelemetry tracing.
Okay. The next question is, can you describe your current methods for monitoring and analyzing the performance of your OpenEdge applications? Are there any pain points or limitations you've encountered in this process?
I think this is kind of a question for the community as a whole, and depending on what they have as their infrastructure, depends on what they're doing, right? Everybody's going to do it a little bit differently. So for us, we obviously not monitoring our OpenEdge applications. We're developing the technology to move away from your homegrown system to an industry standard that's supported by many different vendors out there, whether you want to implement OpenTelemetry yourself or you want to use something like Datadog or New Relic or what have you. There's a bunch of you can plug in open source solutions like Prometheus and what have you. So it really depends on what you have for your existing implementation. And this is a way to standardize that.
Okay, great. This person wants to know, is data masking supported in SQL?
I actually worked on the client side, so I don't know.
Yeah, we have support. I think, Anil, do you want to chime in? I think you may have worked on it, or I think Akhtar's team. But yes, the short of it is yes, dynamic data masking is supported in SQL as well. So if you query the DB, you'll return your query return results with the data mask as well.
Okay. The next question is, what are the benefits of using the various collection objects versus just using temp tables?
Okay, so the built-in collection will provide like performance benefit because this is all done in C. We have implemented everything in the native C code, and also it also bundles with additional benefits like generates and type safety, which means like you don't have to deal with your own types of handling different objects of your own. And this is all comes by default with the in-house, like as I said, like it comes out of the box with the built-in classes, and it is definitely beneficial when compared to the temp table-based approaches.
This next person wants to know approximately how much overhead does OpenTelemetry add to a process?
I can comment unless Anil wants to add to it. It's actually pretty low. Most of the data, depending on how much data you capture, it is offloaded to the background and gathered and periodically pushed to the collector. It's pretty low. Your mileage will vary, as with all of these performance questions.
Yeah.
And so the best thing is to test it out and find out. It depends on how good is your CPU memory? How good is your CPU network? What collector are you using? What format of the collector? There's a long list of what ifs. And so the best answer for those is test it out yourself and see.
Yeah, in addition to that one, it also depends on number of files that we want to trace. Like we tested out internally with one of our customer applications, which has like thousands of ABL files. When we traced all the ABL files, we saw a little bit, but it all depends upon number of files that we want to trace. As I said in the slides, we can use as many files that we want to, or also we can limit number of files with regular expressions and so on. So yeah, it works.
Okay. Great. All right, so we're at the top of the hour, and this is all we have time for today. So thank you, Raphael, Anil, Alex, and Matt. If we didn't get to one of your questions, apologies, but we will make sure we reach out after this call and follow up in the next couple of days. Also, if you didn't get a chance to ask a question, please respond to the email that you will get that has ways to contact us, or just reach out via the Ideas portal or the CVP, and we'll be able to answer things a lot more quickly over there. And thank you to everyone who attended today's webinar, and thank you to our fantastic presenters, and have a great rest of your day. Thank you.